Have you ever dreamed of making something real from your computer? Imagine drawing a toy car on a screen. Then a special machine builds that exact car for you. This is what 3D printing does. It is a way to create solid, three-dimensional objects. These objects are made from a digital file. Think of it like a normal printer that prints letters on paper. But instead of ink on paper, a 3D printer uses materials. It builds up these materials layer by layer. This creates a real object you can hold. It's a truly amazing technology that is changing everything. This process is also called additive manufacturing. The word additive is important here. It means you add material to create something. This is different from old ways of making things. Old methods often involve subtractive manufacturing. This is where you start with a big block of material, then you cut, drill, or shape it. You subtract material to get your final object. 3D printing works the opposite way. It only uses the material it needs. It builds the object from the ground up, one thin slice at a time. This can save material and reduce waste significantly. The importance of 3D printing is growing very fast. It is not just a tool for big companies anymore. It is becoming more common in schools, homes, and small businesses. People are using it to make all sorts of things. They make spare parts for appliances. They create custom phone cases. Artists use it to make sculptures. Doctors even use it to make models of bones. The possibilities seem almost endless. This technology is putting the power to create into more people's hands. It is a big shift in how we think about making things. So 3D printing is really changing the way we make things. It moves production away from giant factories. It can bring manufacturing closer to home, even to your desktop. This means you can design something unique. You can make it quickly. You can create complex shapes that were hard to make before. This freedom opens up new ideas. It allows for more personalized products. We are only just beginning to see what 3D printing can do. It is a key part of a new industrial revolution, a revolution of makers. The journey of a 3D printed object starts with a digital idea. This idea needs to become a digital design. This design is like a detailed map or a blueprint. It tells the 3D printer exactly what to build. People create these designs using special computer software. This software is called computer-aided design, or CAD software. With CAD, you can draw and shape your object in 3 dimensions on the screen. You can make it tall or short, wide or narrow. You can add holes or complex patterns. The design is the very first crucial step in making something real. Once the digital model is ready, it guides the printer. The printer doesn't see a whole object at once. Instead, it sees the object as many thin, flat layers. Think of it like a loaf of sliced bread. Each slice is a layer. The 3D printer builds the object by creating one slice, then the next on top of it. This continues until the entire object is formed. The digital blueprint provides all the information for each tiny layer. The precision of the blueprint directly affects the quality of the final physical object. This means a good design is essential for a good print. The core concept of adding material is truly revolutionary. Traditional manufacturing often involves cutting away material. For example, a sculptor starts with a block of stone. They chip away parts to reveal the statue. This creates waste. 3D printing, however, is additive. It only places material where it is needed. This means less waste, which is better for our planet. It also means you can use materials more efficiently. This can make complex items cheaper to produce in small numbers. This efficiency is one of the biggest advantages of this technology. This additive approach is changing manufacturing thinking. For decades, making complex shapes was very expensive. It required special molds or many complicated steps. With 3D printing, complexity is almost free. The printer doesn't care if a layer is a simple circle or an intricate pattern. It just follows the digital instructions. This opens up amazing possibilities for designers and engineers. They can create lighter, stronger, and more functional parts. They can build things that were impossible to make before using older methods. This is why it's more than just a new tool. It's a new way to create. The first step in 3D printing is to get a digital 3D model. You have a few options here. You can design your own model from scratch. This is done using computer-aided design, CAD software. Many CAD programs are available, some are even free. If you are not a designer, you can download models. Many websites offer vast libraries of 3D models. People share their creations for others to use. Another option is to use a 3D scanner. A 3D scanner can capture the shape of an existing physical object. It then turns that shape into a digital model. Once you have your 3D model, the next step is slicing. The 3D model is a complete solid shape, but the printer needs to build it in layers. Slicing software takes your 3D model. It digitally cuts it into hundreds or thousands of thin horizontal layers. Think of it like an MRI machine. An MRI shows slices of the human body. Slicing software does something similar for your digital object. This software also creates the path the printer head will follow. It tells the printer how to fill in each layer. These instructions are saved in a special file format, often G-code. After slicing, you send this file to the 3D printer. This can be done in several ways. You might connect your computer directly to the printer with a USB cable. Many printers also have SD card slots or USB ports. You can save the G-code file onto a memory card or USB drive. Then you insert it into the printer. Some newer printers can even connect to your Wi-Fi network. This allows you to send files wirelessly from your computer or smartphone. The printer then reads the instructions from this file. Finally, the printing process begins. The 3D printer carefully builds the object, layer by layer. The exact method depends on the type of printer. For many common printers, a nozzle heats up plastic. It then draws each layer with melted plastic. The plastic quickly cools and hardens. Then the build platform moves down slightly, or the nozzle moves up. The printer then draws the next layer on top of the previous one. This continues layer after layer until the entire object is complete. It can take several hours or even days for large or complex objects. The story of 3D printing starts earlier than many people think. The first ideas and patents appeared in the 1980s. A key figure in this early history is Charles Chuck Hull. In 1983, he was working for a company that used UV light. This light was used to harden tabletop coatings. Hull had an idea. What if you could use UV light to harden layers of material? He thought you could build an object layer by layer. This was a groundbreaking concept at the time. He wanted to make plastic prototype parts quickly. In 1986, Chuck Hull patented a technology called stereolithography. This is often shortened to SLA. He also co-founded a company called 3D Systems Corporation. This company built and sold the first commercial 3D printers. These early SLA machines were big and expensive. They used a UV laser to draw on the surface of a vat of liquid photopolymer resin. The laser light hardened the resin where it touched. A platform would then lower the object slightly into the vat. The laser would then draw the next layer. This was the birth of practical additive manufacturing. Initially, 3D printing grew slowly. The machines were costly, the materials were limited, the software was complex to use. For many years, 3D printing was mainly used by large companies. They used it for something called rapid prototyping. This means quickly making a model or a sample of a new product. Before 3D printing, making a prototype could take weeks or months. It often involved expensive tooling. With 3D printing, engineers could design a part on Monday. They could have a physical prototype in their hands by Tuesday or Wednesday. This sped up innovation. A big change happened in the late 2000s. Some of the earliest key patents for 3D printing started to expire. This opened the door for new companies and innovators. Dr. Adrian Boyer started the RepRap project in 2005 at the University of Bath. The goal of RepRap was to create an open-source 3D printer. This printer would be able to print many of its own parts. This meant the printer could replicate itself. This idea, along with expiring patents, helped launch the desktop 3D printing movement. It made the technology much more accessible. Section 5: Evolution: How 3D Printing Grew Up. Over the past few decades, 3D printing technology has improved dramatically. Early machines were slow. They were not always very accurate. The objects they produced often needed a lot of finishing work, but engineers and scientists kept working to make things better. Printers became faster. They could create objects with much finer details. The range of materials expanded beyond basic plastics and resins. This steady progress made 3D printers more reliable and useful for a wider variety of tasks. The machines also started to get smaller and more affordable. Beyond SLA, new 3D printing technologies emerged. Each new method offered different advantages. Fused deposition modeling, or FDM, was developed by Scott Crump in the late 1980s. He later co-founded Stratasys. FDM printers work by extruding melted plastic through a nozzle. This became a very popular technology, especially for lower-cost desktop printers. Selective laser sintering, or SLS, was another important development. SLS uses a laser to fuse powdered materials together. This allowed for printing with strong plastics like nylon and even metals. These new methods broadened the applications of 3D printing. The open source movement played a huge role in making 3D printing popular. The RepRap project was a key driver. Because the designs were open, anyone could build or modify a RepRap printer. This created a global community of makers and tinkerers. They shared ideas, improved designs, and wrote software. This collaborative effort pushed the technology forward quickly. It also helped to drive down the cost of 3D printers. Suddenly, having a 3D printer at home or in a small workshop was no longer a far-fetched dream. It became a reality for many. As a result, 3D printers became much more accessible. What was once a tool for big industry started appearing in schools, libraries, and homes. Small businesses could now afford 3D printers. They could use them to create custom products or specialized tools. Entrepreneurs could quickly turn their ideas into physical prototypes. This democratization of manufacturing is a core part of the maker movement. It empowers individuals to design, create, and innovate. The evolution from expensive lab equipment to affordable desktop machines has been truly transformative for creators everywhere. Section 6. Many kinds exploring different types of 3D printers. One of the most common types of 3D printers is fused deposition modeling, or FDM. You might also hear it called fused filament fabrication, or FFF. These printers are very popular with hobbyists and schools. This is because they are generally affordable and easy to use. FDM printers work by melting a plastic filament. Think of it like a thin string of plastic. The printer feeds this filament through a heated nozzle. The nozzle moves around, drawing each layer with the melted plastic. The plastic cools and hardens quickly. This process repeats layer by layer. Another important type is stereolithography, or SLA. This was one of the very first 3D printing technologies. SLA printers use a liquid material called photopolymer resin. This special resin hardens when exposed to ultraviolet light. An SLA printer has a vat of this resin. A UV laser beam carefully draws the shape of each layer onto the surface of the resin. Where the laser hits, the resin solidifies. A build platform then moves the object slightly. This allows a new layer of liquid resin to cover it. Digital light processing, or DLP, is similar to SLA, but DLP uses a digital projector screen to flash an image of the entire layer at once. Selective laser sintering, or SLS, is a powerful technology often used for industrial parts. SLS printers use powdered materials. These materials can be plastics like nylon or even metals. The printer spreads a thin layer of powder over a build area. A high-power laser then fuses or sinters the powder particles together. It does this selectively, only where the object needs to be solid. The unfused powder around the object acts as a support. This means SLS can create complex shapes without needing separate support structures. After printing, the object is removed from the powder bed. There are other types of 3D printers too, each with its own method. Material jetting printers work a bit like inkjet printers, but instead of jetting drops of ink, they jet drops of photopolymer or wax. These drops build up to form the object and are often cured by UV light. Binder jetting is another method. It uses a liquid binding agent. This agent is selectively deposited to join powder particles. This can be used with sand to make molds for metal casting or with metal powders. Each technology has its strengths, making it suitable for different applications and materials. Section 7. Building blocks, the materials used in 3D printing. Plastics are the most widely used materials in 3D printing, especially for desktop printers. Polylactic acid, or PLA, is very popular. PLA is biodegradable and made from renewable resources like cornstarch or sugarcane. It's easy to print with and comes in many colors. Acrylonitrile butadiene styrene, or ABS, is another common plastic. ABS is stronger and more durable than PLA. It is the same type of plastic used to make Lego bricks. PTG, or polyethylene terephthalate glycol, is also gaining popularity. It offers a good balance of strength, flexibility, and ease of printing. These plastics are usually supplied as filaments on spools. Resins are the key material for SLA and DLP 3D printers. These are liquid photopolymers. They harden when exposed to specific wavelengths of light, usually UV light. Resins can produce objects with very fine details and smooth surfaces. This makes them great for things like jewelry molds, dental models, and intricate figurines. There are many types of resins available. Some are tough and durable. Others are flexible. Some are designed to be castable, meaning they burn away cleanly when used to make metal molds. The choice of resin depends heavily on the desired properties of the final print. For industrial applications, metals are increasingly being 3D printed. Technologies like selective laser sintering, or SLS, selective laser melting, or SLM, and direct metal laser sintering, or DMLS, can print with metal powders. Common metals include aluminum, stainless steel, titanium, and cobalt chrome. 3D printed metal parts can be very strong and lightweight. This makes them ideal for aerospace components, medical implants, and custom tools. Printing with metal is more complex and expensive than printing with plastic, but it opens up new possibilities for manufacturing high-performance parts. Beyond plastics, resins, and metals, a growing range of other materials can be 3D printed. Ceramics can be printed to create art objects or even technical components. Composites, which mix plastics with materials like carbon fiber or fiberglass, can produce very strong and stiff parts. Some printers can even extrude materials like wood-filled filaments, which give objects a wood-like appearance and feel. Researchers are constantly developing new materials. There are even experiments with 3D printing food, like chocolate or pasta. The range of printable materials continues to expand, pushing the boundaries of what 3D printing can achieve. Section 8, Making a Difference, Real-World Uses of 3D Printing. In healthcare, 3D printing is making a huge impact. Doctors and surgeons can create precise anatomical models from patient CT or MRI scans. These models help them plan complex surgeries. This can reduce risks and improve outcomes for patients. Custom-made surgical guides can also be 3D printed. These guides help surgeons drill or cut more accurately. Furthermore, 3D printing is used to make personalized prosthetic limbs and orthotic devices. These can be perfectly tailored to fit the individual user. Scientists are even working on bioprinting, which involves printing with living cells to create tissues and organs. Manufacturing industries use 3D printing extensively. One of its earliest and still most common uses is rapid prototyping. Companies can quickly create physical models of new designs. This allows them to test form, fit, and function before committing to expensive mass production. Beyond prototypes, 3D printing is used to make custom tools, jigs, and fixtures. These items help workers on assembly lines. They can improve efficiency and accuracy. For some products, 3D printing is even used for small batch production of final parts. This is especially true for items that need high customization or have complex designs. The aerospace and automotive industries also benefit greatly from 3D printing. These industries need parts that are both lightweight and strong. 3D printing allows engineers to design parts with very complex internal structures. These structures can reduce weight without sacrificing strength. This is crucial for improving fuel efficiency in airplanes and cars. Companies like Boeing and SpaceX use 3D printed parts in their aircraft and rockets. Car manufacturers use it for prototyping new car designs. They also use it for creating custom parts for high-performance vehicles or classic car restorations. This speeds up innovation significantly. Education and art are other fields where 3D printing shines. In schools, 3D printers are powerful learning tools. Students can design and print their own creations. This helps them understand concepts in science, technology, engineering, art, and math. Architects use 3D printing to create detailed models of buildings. Artists and designers use it to bring their unique visions to life. They can produce intricate sculptures or custom jewelry. Hobbyists use 3D printers to make everything from game pieces to useful household gadgets. It empowers creativity and allows for unique expression in many forms. Section 9. The future is now. What's next for 3D printing? To sum up, 3D printing is a remarkable technology. It builds objects layer by layer from a digital design. This additive process offers many benefits. It allows for incredible customization. You can make items perfectly suited to your needs. It speeds up the process of turning ideas into real things. This is especially true for prototypes. It can also reduce waste compared to traditional manufacturing. It only uses the material needed for the object itself. These core advantages are why 3D printing is becoming so important across many fields, from medicine to making. The potential impact of 3D printing on the future is immense. It is already starting to disrupt traditional manufacturing. It can change how supply chains work. Instead of shipping parts around the world, companies might send digital files. The parts could then be printed locally, when and where they are needed. This is called distributed manufacturing. It could make businesses more resilient. It could also reduce the environmental impact of shipping goods. Imagine a future where spare parts are printed on demand rather than stored in huge warehouses for years. We can expect many exciting future trends in 3D printing. Printers will likely become even faster and more precise. New materials will continue to be developed. These might include smarter materials that can change shape or respond to their environment. Artificial intelligence could play a bigger role. AI could help optimize designs for 3D printing. It could also monitor the printing process in real time to improve quality. We might see more hybrid machines. These machines could combine 3D printing with other manufacturing processes like CNC milling all in one box. 3D printing is more than just a new way to make things. It empowers individuals and businesses. It allows anyone to become a maker. It democratizes design and production. As this technology continues to evolve, it will unlock new innovations. It will help solve complex problems. It will shape the way we live, work, and create in the years to come. The future of 3D printing is not just about faster machines or new materials. It is about a future where we can make almost anything we can imagine. The revolution of making is truly here, and it is being built layer by layer.